Welcome everybody to today's SEFM Day. We have really exciting topics on the program, and we start today morning with Roberto. Roberto was born in Italy. He studied there, also made his PhD there on isomorphism of types. So he started in the theory. Currently, he's a full professor in Paris, and his research areas are extremely wide. So I'm very impressed. He is theoretically very experienced, functional programming, parallel distributed computing, semantics of programming languages, type systems, as from the PhD, rewriting, linear logic, static analysis, so wide range. And recently he also moved towards a very important topic that is yet not as central as it deserves to be. And this is software, free software, and how to handle related questions. And the title of his talk today is Making Software a First-Class Citizen in the Scholarly World. So I'm excited to listen what you have to say.
Okay, thanks a lot, Erika, for the very kind words. First of all, I'm absolutely delighted to be with you today, even if kind of virtually. I hope next time it will be in presence. As Paula said yesterday, I have added Amsterdam in the location, virtual location of the conference today. I'm hoping that we will manage to go there tomorrow. Tomorrow, someday in the future. So the idea today is to share with you a concern about the importance of software. We are all studying software, developing software, providing the principles that allow us and everybody else to build better software. But what about software itself? Okay. And what can we do to make it a first-class citizen in the scholarly world? Let me share with you a little bit of the work I have been doing with my team over the past 5 years, and I hope to see more and more people getting interested in it. So the first observation is that, of course, and in particular today, with the critical situation we are living in, everybody around us has discovered how software is important in our work. It is the fuel of innovation, the engine for our industry, it's a pillar for academic research, of course, so this is very clear. But unfortunately, not many of the people around us know that software doesn't come out of the blue. It is not just something that you run by pushing on a button in your phone. It is actually written by people, written by developers, written by experts in the form of software source code. Well, for us, of course, this is not new at all. I remember when I was a student in Pisa, and Paula was one of my professors, by the way, I read a beautiful book by Jared Adelson, which is Structure Interpretation of Computer Programs. And I remember that in the preface of the first edition, there is this beautiful phrase. He says, programs must be written for people to read and only incidentally for machines to execute. Well, of course, you can think this is a kind of a joke by a professor telling the students, if you turn in a homework I cannot read, you will have a bad grade. But actually, the observation is much deeper than that. Is that software is in some sense, of course, source code, of course, it is meant to be compiled and executed on a machine, but it is also a message sent from the original developer to the person that will need to fix a bug, to adapt it, to evolve it, to understand what is going on. And this message is so clear today that we have access to tons and tons of important pieces, jewels of software source code that were not available when R. Davidson wrote this book, because in the 80s, most of the source code was hidden behind closed doors in companies, right? But look at what we have access to today. So for example, this is a small excerpt of the source code of the Apollo guidance computer that actually helped mankind put a man on the moon. And I would like to remember here that if we managed to put a man on the moon, it is thanks to a lady, Margaret Hamilton, that actually directed the team of programmers that wrote this. If you look at the source code, on the left, of course, you recognize some old style assembler. But I would like to focus more on the right part. On the right part, there are the comments. You see, these are clear messages, not for the machine. They are sent to the other people that we have to actually understand what is going on when something goes wrong, for example. So, I mean, the code is very nice. I mean, if you look at it, it starts by checking. It is a piece of code which is executed when you go to the moon. You have the landing module that is approaching the surface of the moon. And if you remember the movies, because we have seen all of them, we saw that, all of us, we saw that. There is a point where you need to turn the LEM around, the module around, because instead of looking at the moon, you want to avoid crashing. So you need to put the legs on the bottom. So how does it work? I mean, it checks whether a certain antenna is a specific position, which is a sensor to tell you if you are already in the right position. If it is not, then you ask the astronaut to actually turn the module around. Then, I mean, for all the hackers like me, there is a funny way of actually calling a routine. And then if the answer is yes, you return to n+1, otherwise you return to n+2. And then, so depending on the answer of the astronaut, you can abort the procedure or say, okay, he said I turned the LEM around, but in that case, you don't trust him. It is written, see if he's lying. And actually you jump back to the routine to see if the antenna is still in the right position. If it is not the case, you keep bugging the astronaut. Okay, that's fascinating. There are other more recent pieces of software source code. For example, this is a small excerpt of the Quake 3 Arena game. I do not know if all of you remember that. I mean, think about Call of Duty, okay? These kind of things where some of our kids spend too much time. I'm a first-person shooting. But forget for a moment about the game. The point here, this is a routine which is extremely important when you do 3D animation, or actually 2D and a half, as it was in that case. And here you need to compute 1 over square root of x without using the floating point coprocessor because it was too slow at the moment to play the game. And actually, it will take you a full afternoon to understand what is exactly going on in here. And actually, the guy who reused this piece of code didn't necessarily fully understand what is going on. If you look at this comment here, I do not know if it shows up. You see here, I will not pronounce what is written here, but essentially, if you are curious, just go and check just for this particular hash number here, hexadecimal number here, 5F3759DF in Wikipedia, and there is a full page explaining what is going actually on there. Why am I spending so much time on this? Apart from the fact that it is beautiful, because I really want to convey the message that source code is much more than just an executable. And of course, all these comments, all this extra information, the names of the variables, the names of the function, the way software is written, this is not for the machine. This is for us, okay, to understand what is going on. So to put it like Len Shustek, who is the board director of the Computer History Museum, a beautiful institution in Mountain View that actually tried to rebuild the history of computing. He has a beautiful paper in 2006 in the Annals of the History of Computing, IEEE, and he says source code provides a view into the mind of the designer. See, so that's an incredible observation that unfortunately people that never saw source code have difficulty understanding. But now, I mean, there is more teaching of computing in high school, etc. So I hope that this kind of literature, technical literature of 21st century is going to be better appreciated by the next generations, our kids. Now, so another little bit of time to tell you about why I consider source code is so special. You know, we have been discussing with people which are interested in open science in general, etc. And it is remarkable how even the word software is missing in most of the documents you see around and people talking about open science, or even at the European level, etc. They tend to tell you, well, we didn't forget. It is just that software is a special kind of data. Well, I pretend software is not a special kind of data. It's much more. So software evolves over time. Projects may last decades with big teams working on them. if you want to understand what is going on, you need to have access to the development history. You do not read 1 million lines of code from scratch. You need to know why a particular line of code is there, and this is in the version of the history. The other point, it is extremely complex. Today, you have projects which are millions of lines of code, but you also have the case where a single line of code that you write for a particular application which is interesting for you actually pulls in, build upon tons of extra components you didn't write. So the small picture you see on the right here of the screen is actually, well, unless zoom it out, I mean, the picture that you see in the screen is just a visualization of the so many dependencies which are pulled in as soon as you type import matplotlib in Python, which is something a lot of data scientists do today. So there are sophisticated developer communities, and also research software is just a thin layer on top of all the rest, which is developed by tens of millions of people around the world who are not scientists. And so the other point is that this is precious knowledge, a new form of precious knowledge, which is executable but human readable, where we didn't actually take care of it. We are not taking care of it. I mean, key people that wrote the original pieces of source code on top of which, for example, the internet is built, are passing away and with knowledge, and we are not collecting this knowledge, which is dismaying for me, because, you know, I mean, for mathematician, if you could, as a mathematician, go back and talk to Euler or to Leibniz or to these people, it would be fantastic, but they cannot. We can go back and talk to the people that created all this field where we are working. We should do it. And then at the other side, there are also platforms that all of us and all the developers worldwide use without even thinking. I mean, these code hosting platforms which are shared around the world. There are tons of them, we will see, which are closing down. I mean, 2015, Google Code closed it down. Gitorios closed it down. That was 1.5 million open source project endangered by a single business decision. I mean, could you believe this? And there was no organized effort to catalog and archive all this knowledge. So this is a general observation. Then when you move to science, to our work, what I told you, I mean, people talk a lot about open science, but 90% of our time is spent talking about open access and how to fix the mess where we are today with commercial publishing that is actually preventing a lot of people from accessing knowledge. Then there is a small effort to talk about data. Actually, smaller, I mean, less visible than what you see about open access. And next to nothing about software. We should pretend that software source code is one of the 3 pillars of open science. There are not just 2. It is not just article and data. It's article, data, and software. And of course, the link between them, how I can make sure in a paper that I mentioned that this particular version of software used on that particular status of the data has been used to compute a particular result that happens to be 42. So once you recognize this is a pillar of open science, then you can ask yourself, what are the needs that we need to address? And so there are a plurality of needs. I mean, if you are a researcher, think of ourselves just as researchers, forget about your hat as a department director or something like this. Well, I need a place where I can put the software which is associated to my paper or the software I'm developing and reference it in my article in such a way that I'm sure that the reference will stay there for the long time, will not go away. And I need to choose the best way of doing this. I want to find software which is useful. Of course, I would like to be credited for the work I'm doing if somebody else is reusing my software in their work. And when I get an article from somebody else that pretend to have a particular result, I would like to just be able to check it, okay? Or build on top of what these people did and adapt it. You remember, I look at the comments and make changes and adapt it for my needs. This is as a basic researcher. Then you may be a team leader or a dean, and then you have other issues. Of course, this becomes more administrative, so you need to have the web page with all the contribution from the departments, of course, the list of the papers, but also the list of software contribution. for your reports. I forgot, even a researcher, yes, you need to write up your curriculum vitae, apply for funding, all this kind of thing, and you would like to have a structured way of presenting your software contribution, not ad hoc. And then if you are a funding organization or research organization, you need to track what are your software assets. Software is part of the production of research. So, what about technology transfer? What are we producing? And unfortunately, but we should not hide, I mean, metrics, okay? So who has the most influential piece of software? What are the 5 most influential software of your university? This kind of thing, you know. It is just around the corner. It's not avoidable. So let's try at least to make it work as decently as we can and avoid the number game we are victims in publications. Well, that being said, unfortunately, the situation today is not ideal. So where do we stand? In software engineering and in computer science more in general, so I look at there because we are the expert in software, right? So we should be the guy that do the best work. Not really. So if you look at some literature in software engineering, there is a paper by Zanier and others in 2006 actually analyzed all the history of the ICSE conference, and they found out there was not a single replication study. Carlo Ghezzi gave a keynote in ICSE 2009, and he looked at everything in TOSEM from 2001 to 2006. And out of all the papers that had mentioned tools, only 20% had enough information to get tools that could be installed in some way, which is surprising. I mean, particularly in software engineering, come on, I mean, you should be expert, right? And then there is a more recent work in 2015 by Christian Kohlberg, where actually he analyzed over 600 papers from in a ton of the most prestigious conferences and journals in applied computing, and there only 40% was installable. And the main reason is that source code or the right version of it could not be found. There was no way to. But the situation is slowly changing. So around 2010, many communities started to wake up and worry about this. I have to say that as far as I understand, unfortunately, this didn't start from us. It started from people in applied mathematics, in biology, in medicine, etc. But I mean, we are catching up. So for example, there are policies. Many of the conference in computer science now, when there is an applied side, set up an artifact evaluation committee that actually allows to look at the artifact associated to paper check that they work. ACM has started a policy about artifact reviewing and badging. I mean, these are good things. There are discussions in many working groups in the Research Data Alliance, data, not software, and then for C11, which is another structure in the US. Some journals actually started to notice the issue and do something. The best I know of is IPOL. We'll come back to it, but there are a few others that are trying to allow you to actually put your artifact somewhere next to the paper. Then some generalist repositories that allow you to deposit any kind of data or things like Figshare or Zenode or something like this. Well, a sequence of bit is a sequence of bit, right? So they actually added a tag which is called software, and so if you deposit something which is a zip file that happens to contain software, you already saved your software. But this is just software handled as just data, which is not what I think is the best thing to do. The point is that, yes, there has been an awakening, but a lot has to be done. And if you look at what we actually need to address our needs and our concerns, there are actually 4 things, 4 issues that I believe we need to address, and I'm presenting them to you in what I believe to be, I mean, it's my personal opinion, of what it is the order of difficulty of addressing these issues well. So the first issue, of course, not losing our software. So you need to have a place where we can archive this software, which is different from developing. I mean, archiving is a place where you put something that stays there. Why? Because we need to make sure that later on, when somebody reads the paper, is able to retrieve it, no matter whether your GitHub account has gone away or something like this. This, again, is pretty easy to do. You put the zip file in a standard archive. Not the best thing you can do, but that's easy. You can do it better, you will see how to do it, but archiving is not a big deal, no longer a big deal. Identifying software for referencing them, that's more complicated, because now you need to find identifiers that will be there for the long term and which are appropriate for software. And we will see this is not what we are used to do for publications. It's a different issue. And this, of course, is important for reproducibility. Then if you want to find software or describe it, and know if you want to can you reuse it, and what is a license, for example, then you need a proper metadata to describe it. And this is important for visibility and reuse. And finally, last but not least, how to go about citation and credit. Okay, so research software artifacts should be properly cited, which is not the same reference. When I say cite, I think of giving credit to the authors. So first step is, who are the authors? And with software, that's much more complicated than one can think. And so if we actually want to address all these four things, A, R, D, C, which is kind of different from what people talk about in the data space, which is FAIR, F-A-I-R, then we need infrastructure which are designed for software source code, not just adapt other infrastructure built for data to handle source code. Now, the good news is today we have one. And this is the core of the presentation. So that was a big introduction, but just to give you the landscape of where we stand and what we need. So this infrastructure we have been building for some 5 years now, it is called software heritage. What is it? What is it? But in a nutshell, this is, you can think is a kind of a Library of Alexandria source code, and it is built by an initiative whose goal is precisely to go out and collect every single line of source code for every piece of software that is still available. Preserve it, making sure we don't lose it, and share, making it accessible to everybody. There are 3 dimensions here. The past, preserving the past, the Apollo 11 source code, looking at what is going on right now, because it's not just an archive of dusty old source code. It is for the lines of code written yesterday by one of your students or by yourselves, and a kind of tool to build better science in the future, so past, present, and future. And if you materialize this a little bit, I mean, what Software Heritage is building is a reference catalog of all the software out there. Of course, there is software in many different places, in particular open source software on GitHub, on your institutional code hosting platform, on the one of your friends of the European project or whatever. But the point is they're all spread around. I mean, we are building a single catalog where everything is indexed. We are building an archive. And again, think again about what you do when you do software development. A code hosting platform where you work collaboratively on software is just a place where you go, you create a project, you work on it, then maybe you close it down, you move it elsewhere, you rename it, or the platform goes away, like Gitorious and Google Code. So it is not an archive. And we need an archive. And finally, last but not least, we want to put the first brick in the wall that is needed to build a large telescope for analyzing the galaxy of software development worldwide, a kind of big research instrument for all of us. Our friends, and I have a friend in that space, in astrophysics managed to have beautiful instruments to observe the galaxy. We as researchers in computing, we should have a large instrument to actually observe the galaxy of software development, which is still not there. Well, this is an initiative. It has taken time to build support for it because it is a long-term undertaking. Okay. So you need both visibility and support, people that share your vision and provide the message that this infrastructure is actually universal and not just a research project or just something that belongs to a particular country. That's the reason why we have agreements with UNESCO, and we work with UNESCO here and support from many organizations, including learner societies that you recognize. And on the other side, we had to bring together financial support, because an infrastructure has a cost and you need to foot the bill at the end. You make sure it will stay there for the long term. So the initial effort was made by INRIA. I'm very grateful for that, to them for doing that. But then the idea since day one, like for the World Wide Web Consortium, and I was delighted to have Jean-François Dramatique, who was the first CEO of the World Wide Web Consortium, as advisor in building the strategy. We are trying to bring together a diverse set of stakeholders, of funders and supporters, that goes from IT companies to banks, to telecom providers, to the Ministry of Research in France, to different prestigious universities, University of Paris, University of Pisa, that was mine, the University of Bologna, the University of Quebec, the National Archives for Data in the Netherlands, and then different other organizations, including even code hosting platforms like GitHub and many others that should come later on. Okay, it is built for the long term, and it is thought as, I do not have enough time. No, let's see. So building for the long term is doing this, then also working to raise awareness about software source code. At UNESCO, actually, a couple of years ago, we convened 40 experts worldwide. Paula was also there. I think she remembers. You can see her with a red dress in the picture. And that there were people from any kind of places. I mean, from private foundation to historians, to librarians, to universities, open source experts, etc. That ended up in a call, in the Paris call, about the importance of software source code, raising awareness about this, okay, way beyond research. This code is published, and actually, if you want, you can sign it. And to do not lose time trying to write down, I will share the slides, and the links are clickable, so you can go there after that. So this is a political overview of how it works. Again, as a strategy, we are building the largest software archive as a shared infrastructure, and the idea is to be just an infrastructure. So we want to enable application in cultural heritage, in industry, in research, in education, but we are not building any. So we provide the infrastructure on top of which people can build it, and it's already complicated enough this way. And if you look at the website that we see later on, it is already the largest archive of software source code ever built. So we have over 140 million projects already archived today, and using a special structure, which is a Merkle direct acyclic graph that allows actually to deduplicate massively the contents. And it's almost 9 billions of individual source code files. You see almost 40 million of different authors working on this. I mean, that's a huge archive. And how is software heritage now addressing, now I'm trying to connect to what I told you before, addressing these four needs: archive, reference, describe, cite. So the big mission of software heritage is more in the archive and reference area, but we also care about describe and cite. So in the slide that I'm going to show you, you will see archive and reference are very big, describe and cite are smaller, not because we don't care about that, but because it is not the core mission. So for archiving and making sure nothing is lost, we have actually three different strategies. The first one, we are building a gigantic crawler for software source code. So we connect to tons of different code hosting platforms out there, to GitHub, to GitLab, to instances of GitLab, to Bitbucket, to you name it. And then to package managers or package distributions. And we proactively collect everything which is there. When we get all this data, you will find out that it's still a kind of a Babel tower. You need to connect to all these different platforms that use all different APIs and languages. So you need adapter. But then when you have the list of projects hosted there, some are developed using a version control name, system name like Git, other use Mercurial, other use Darks, other use Subversion, other use you name it. Or if you have packages, some are JavaScript packages or Camel packages, R packages, Debian packages, all different. So since we are not just build an old style archive, we are not building just an old style archive, we go the extra mile to actually build converters that convert each of these different formats into a single gigantic data structure, which is this gigantic Merkle graph where every file is connected to the directory where it is stored, and every directory is connected to the many, many, many different commits where it may appear. And these commits connected to the many, many different origins where it can be found. So this strategy actually allows you to get rid of the duplication that comes from fork, either explicit or implicit. And so this is harvesting. But we also have ways of allowing you to actually proactively add software to the archive. One is through a simple interface that doesn't require a username or nothing, which is save.software.org, that allows you to trigger archive of a particular repository, not necessarily yours, something that you need to archive and reference, or an API for an explicit deposit, which is called deposit.software.org. This is for curated deposit. So this is what we do for archiving. And then what about referencing? We use a special kind of identifier for reference of the artifacts which are in the archive, which are intrinsic identifier, decentralized, cryptographical strong identifier. The code name is SWHID, SWID, for software identifier. This is standardized, normalized, now supported by industry in an industry standard which is called SPDX. It is also supported in Wikidata. The prefix is registered with ARIANA. And I will show you how it works in a second, looking at the demo. But if you manage to see in the slide, you don't know if it is big enough. I mean, the identifier is basically a prefix, SWH. I mean, this is an identifier software relative. The version number, because the schema can evolve. So now it is SWH:1. Then the kind of the object that is being identified. And this kind of object can be a file content, a directory, a revision, a release, a snapshot of the full development system. And then you have a hash. And this is a hash which is computed on the file or through the Merkle tree structure at the root of the subtree or subgraph that you want to designate. So archive and reference, I think we have the best solution out there. Then the issue is, what about describing software? Well, it's a mess. There are too many ontologies and metadata schema out there, but we are actually trying to work with one of the entities that is working on something called code meta and try to provide a means to add intrinsic metadata to the source code itself. So if you deposit a file in your source code project, then we automatically be recognized. And for citation, again, and giving credit, well, I do not know if you have been surprised, but I have been using LaTeX and BibTeX for 35 years, maybe. There is not an entry for software. So I do not know what you do, but what I used to do, I was abusing the MISC entry in BibTeX to some kind of message link to software. Really? I mean, in 35 years, we didn't have a style for citing software. That's unbelievable. Well, fear not. I mean, thanks to the lockdown, I found time for a week to sit down, and now that you have a style design for software, LaTeX software available in Citan, already in TechLive, that I developed a few months ago, and you can cite software precisely. We will see in the demo in a few seconds. But again, it is the full picture where we try to contribute, even if our main business is archiving and references. Now, that was long. And I think an example is worth a million words, okay? So let's try to look at some example of what this is. Now, bear with me a second. I need to switch from this to the browser. So I need to stop sharing this. And I need to go to share. How can I share? Wait a second. This share. There are messages in the chat. No, it's not important. So share, no, application advanced, no. Subject. Where is the Chrome browser? New tab Chrome browser. It should be this one. Let's see if it works. Aha, it seemed to work. Do you see an empty Chrome browser? Okay, fantastic.
Yes, perfect.
Okay, so the first thing, I would like to introduce you to the Software Heritage Archive itself. Okay, so if you go to archive.softwareheritage.org, as you see here, you see an overview of what we are archiving, so the different platforms which are regularly harvested by our crawlers up to now. Many things, very, very big platforms like GitHub, down to small platforms like the INRIA institutional repository, for example, which is crawled regularly, or the Python package index, or the NPM JavaScript package index, or Debian, or the CRAN, etc., etc. And you will see that, by the way, Google Code and Gitorious, I told you, they were shut down in 2015, but luckily we were already around. So we managed to salvage the 1.5 million project before the platform were shut down. Everything is in there. Okay. So if you have old papers linking to software that was on Gitorious, on Google Code, which was my case, for example, fear not, you can still find what you did. These are the actual number. You see it change a little bit from the picture that I showed in the slide because it changes every day. And now you can go in the archive and look, for example, for the Apollo 11 source code. The search functionality is bare bone for the moment. It's just in the URLs of the repository that we have archived. Full text search will require more money, more machines will come later. So for example, this is one of the many copies of the Apollo 11 source code which are available there. If you go to Luminary, for example, there is one piece that I like a lot. I mean, this burn, baby burn master ignition routine of the LAMP, where you will see, again, a little moment of pleasure. We see the master ignition routine is designed for use by the following LAMP programs: P12, P40, P42, P61, P63. Okay, and so remember, we are in the 60s, so we are starting to learn programming. Now you need to handle 5 different kinds of commands that the astronaut can give. What do they do? And you have limited space, okay? What do? They have a single routine that actually handles these 5 tasks. And the way the routines are accommodated to the different tasks is by passing table of constants. Okay? These are routines that actually turn on or off the rocket. Okay? So you see, variations among programs are accommodated by means of tables containing constants. So this, again, messages to the other developers. And then a little bit of ego, pride here. The master initial routine was conceived and executed in the 60s, executed and written, and notably is maintained by Adler and Ives, brilliant engineers, which are Ayrton Ives is still alive. And then you find this, Honni soit qui mal y pense, in the comments of the program. That would be a long story. I mean, if you want to know, ask me in the question time, I'll tell you. Otherwise, I will go over time. And then when the real routines come here, it's so serious, you should not touch them because otherwise people die. It goes too late in noli se tangere, don't touch unless you know what is going. You wouldn't expect something like this in source code in the 60s, right? And now you want to tell your friends, you want to put it in a blog post or in a paper. Okay, so you click on the first line, you shift click on the second line, and then you open this red permalinks tab that you see here. Wait, I need to, that you see here. And now you see, you can get the link to the file content we are seeing, the content here, or to the directory that contains it, or to the revision that contains it, or to the snapshot of the full state of development of the software where this piece of file is contained. And when you go to this content tab, for example, you can get either the simple software edge identifier, as I told you, the prefix, which is registered with IANA, SWH, the version one, it is a content, a tag for the content, so it is exactly for this file, and then the hash. In this case, the only thing you know, it is the file that has the hash. You don't even know the file name or where it comes from. Or you can add contextual information. In this case, you know, actually, this file has been found, harvested from the repository Apollo 11 in the Chris Olgari organization from GitHub. The state of the repository when we visited is identified by this snapshot identifier. The file name is actually, the path to the file is luminary, burn, baby, burn, etc. The lines I'm interested in, highlighted at 58 to 72, and this file is inside the revision, the anchor in the graph, which is identified by this identifier. So if you have this and you copy this permalink, you can copy the identifier or the permalink. The permalink is just a resolver concatenated with the identifier. Then if you put in a paper of yours, or in a blog post, or in Twitter, or wherever, and you actually paste it, you click on it, I'm simulating clicking by pasting in a new tab, what happens is that you are brought exactly to the same place in the archive. If my connection goes, let's see, come on. Here it is. You see? So I'm brought exactly in the same place, in front of the same fragment of code, but it is not just that. Look up. You see, you have the full context. It is inside the same revision with the same author name, okay? In the same branch, in exactly the same path. So you have exactly all the information needed to bring your reader or yourself to exactly the same place where it was. So this is a functionality which is also available on code hosting platform. But the big difference with code hosting platforms is that code hosting platforms go away and projects go away, and the identifier on code hosting platform are all different. While in software heritage, the identifiers are all the same. It doesn't matter if it comes from a Git repository, Subversion repository, a package, whatever. The presentation is uniform, the data structure is uniform, the identification system is the same. See? Once you do this, then you can start writing papers in a way which is something I wanted to do for decades. I do not have time to go through all the demos because I had prepared a ton, but I speak too much. So let me just show you one case. So this is one article. Let me put it big. One article that I wrote with a friend this year about a replication experiment on a software source code that we wrote together in 1998, so 22 years ago. We wanted to see if it was possible to still run it. I mean, the big surprise, it was written in OCaml, beautiful language, so just compile and run still today, 22 years ago. The big difficulty was finding the source code. I have to admit, I lost it. Okay. But we found it, and guess where? In software heritage. How? Because somebody posted it to Gitorious, but Gitorious has gone, but we saved it. So we found it. Incredible. So I could get back all the history of the system. And now this paper describes the experiment, what we did. And if you look at what happens, you see now the code is available at this address, etc., etc. So you have the software ID all over the paper. That allows you to, for example, do things like this. Let me see if I can find the part which is. So in the paper, I'm explaining we needed to change a line to make it work, just one line. And this is the line we needed to change. And you see in the paper, I can put the precise reference to it. Now, the other thing which is interesting is that when we mention in the paper the different things that we can do on the article, for example, here this is an excerpt of the source code which was in the original paper, and then we can again go to the exact release and version of the file that has been used for this particular application. All the paper is done like this, and if I can go back to the bibliography, sorry, not very structured my presentation here. In the bibliography, what you see that now you have real entries for software which are clearly identified, which are written using this spatial extension of bibliotech, which is dedicated to software. So you have the possibility of mentioning software, like this one, but also software releases, okay, particular version, or software excerpts, fragments of code. You see, and so again, if you click here on the software release, you end up on the particular version of the source code you are interested in. If you click on a particular excerpt link, then you get the fragment of code that was actually meant to be shown to you in the program. So I'm very speeding up a little bit too much in this. I'm sorry for not being very, because I'm seeing the time is running out. But again, this is a way of changing the way we actually can write your papers. And now, what about if the piece of software you're interested in is not already in the archive? That's very easy. You can go to this particular page, which is called Save Code Now. And there you can tell our system, the crawler, for now there are 3 version control systems which are supported, Git, Subversion, and Mercurial. You can put here the origin that you're interested in. For example, I do not know, I mean, this project by Len Shustek on GitHub. You submit the request for archival, and that's it. No username, no sign up, no login, nothing. And then you see in the browse save request tab, you see all the requests that has been submitted. So the one I just submitted is this one, has been accepted because it is an origin we know. It is not yet scheduled, it will be. If it is a strange place we don't know, this end up on the desk of one of the engineers that checks it is actually a legitimate piece of source code before accepting it and whitelisting it, and then it goes on. You have seen there have already been 11,000 requests manually submitted by people that wanted their software to be archived. Imagine you have to write a paper and your software is on some repository somewhere, you want it to be archived to have the proper software identifier, so you just go in there and submit it. Okay, so I will stop the demo part here and go back because I have eaten up a lot of time, so let me move to the end of the story. In this slide that you have here, you will have the copy of my slides. All the blue things are links, so you can follow all these links by yourself and try many other things by yourself. Before concluding, a few words on what is going on here. First of all, a remark on the identifiers, right? Because what you have seen are strange identifiers. If you are a developer, you are familiar with them. I mean, when you use a distributed version control system, we all use these kinds of identifiers, even if each version control system has another one. If you're not a developer, you may wonder why not using other identifiers you are more familiar with, like DOIs, for example, for identifying software. So let me take a few seconds to tell you a little more about the trust model in the systems of identifiers. Think a little bit about the identifiers. There are actually 2 general classes of system of identifiers. Intrinsic identifiers, which are actually computed from the object. There you do not need a registry. Okay? For example, the chemical notation. If you find on a paper NaCl, that's a sodium chlorure, that is a table salt. Okay, you don't need to click on a link to know what it is. It is a standard coding of that particular object in chemistry. And there are thousands of components, but the standard coding allows you to have a uniform system identifier which is computed from the object. In music, it's similar. In computing, we have hashes, and now you have short range identifier. These are intrinsic identifier, no registry needed, and persistent in the long term. Then you have extrinsic identifiers. These are assigned to you by an authority, and it needs a registry, and it needs an authority. Your passport number. There is no connection between your passport number and you. It is not the hash of your DNA sequence. Okay? It's just a number given you by an authority. All of the usual system of identifier we use in academia, DOIs, ARCI, RRD, etc., are extrinsic identifier. Okay, so you have an authority in the registry. And so the trust model, there is a dedicated blog post on this if you want to look at that. The trust model is pretty different between the first and the second. If you have an extrinsic identifier and you try to retrieve a piece of data associated to it, you need to go into the registry that tells you, this identifier corresponds to this URL. Okay, so you follow the URL, you go to the software archive, get the software in there that maybe has a checksum, but this checksum is just to ensure it is not corrupted during transmission. And then you get it, but you need to trust the full red zone here. It means anybody in this full red zone could change the content and you wouldn't notice if you only have the identifier. With intrinsic identifier, that's pretty different. Because if my identifier is computed from the object, when I fetch the object, then I just check if computing the identifier from the object gives the same result. In that case, I'm sure. And that's it. The only thing I need to trust is the algorithm, okay, the hashing routine that has no bugs or something like this. So it's a very, very different things when you think about the long term. And so the road ahead. First of all, adoption is coming. So in France, we have this national access portal that now allows people to deposit software. There are just a couple of hundred deposits done right way. But this is curated deposit. So then it goes to software heritage. It is a metadata which is curated. SWMath, which is a beautiful archive for mathematical software, links into software heritage for long-term reference to the software they describe. Journals. I mean, the image processing online, which is an incredible journal that actually publishes articles by algorithm with associated source code, actually archives and reference software in software heritage, and actually even provides for you the bibliothèque template for the software they publish. Just this weekend, somebody from the Journal of Theoretical and Computation and Applied Mechanics got in touch to let us know that now there are instructions for authors that recommend archival in software heritage, and they included the bibliothèque software package in their journal class to allow people to cite software in that particular way. From the policy level, you have in France a national plan for open science includes software heritage in infrastructure, and we have published self-archival guidelines with the full ICMS paper, which is available online that you can look at. Let me be clear. This is not telling what a beautiful work we did. This is not my goal. I'm just telling you, we are starting from zero. There was nothing. To get adoption and to have an infrastructure that serves all our needs, it takes a lot of effort. It takes advocacy. It takes time. It takes convincing people, telling friends like you in our community. That's a pleasure to be with you today about this. It takes a lot of time. I mean, and it's only now, I mean, 5 years after starting this, this adoption is actually starting to take place. I'm telling you how long and how difficult it is to get here. And the breaking news, and you know, I mean, it happened again. Okay, Bitbucket, another popular platform, announced almost 1 year ago that they were going to close down support for Mercurial, which endangered 250,000 of research projects. Okay? And So we noticed that, so we teamed up with Octopus, they are experts about this Mercurial version control system, get funded by a foundation in the Netherlands, NNet. And in July, just a few months ago, Bitbucket erased 250,000 repositories, but in August we were ready, and you had the archive live. So everything that was in Bitbucket is live. And what is funny is that we got this tweet by a researcher in astrophysics that you can read it. I mean, just realize that Bitbucket disabled all the repositories when somebody informed me that the link associated with an older pattern of mine was down. I thought all was lost, but someone archived all the reports. Very classy move by Octopus and software. And he found all his stuff back. So the bottom line here is that, of course, explicit deposit, telling people you need to go and deposit today is important, we must promote it, but it's not enough. Okay, not everybody will do it. And what about people who are not researchers, do not want to archive in the node or something like this? We need to collect everything to make it work. So let me finish here. I think the key message that I wanted to deliver is that we all need to take responsibility to make sure research software becomes a first-class citizen. So at least making sure it is properly archived, properly referenced, properly described, and properly cited. So you can now already, if you want, leverage this infrastructure, which is software heritage, in the conferences, in the journal, in the artifact evaluation committee for archival and for reference. You can finally cite software, at least if you use LaTeX. In Word it's more complicated, but I mean, in deep LaTeX, software is there. And also another thing, if I can, and if I may, we have been part of a conversation about software citation and software evaluation for at least a couple of years. I have to say, I didn't see enough colleagues in there. It's an important conversation. So if you do not want to succumb to number games again in 5 years, where you will have a Shanghai classification of software producing university or something that's built on strange indicators, this is a moment to join the conversation and tell how you want to have your research software evaluated and cited properly. Don't let other people do it for you. Then finally, a point I could not talk about today, and sorry, I mean, it's very complicated to shrink 5 years of work into a few slides. Even if I talk a lot, there are incredibly interesting scientific problems in building this infrastructure, just in building it. I mean, big code, automatic classification, distributed infrastructure, it's an incredible playground. This will need to wait for another moment, but just to hint the fact that if you come and look at our blogs of publication, we see there is ground for a lot of people, and we as a community, we need to take care of these issues. So sorry again for being so long. I think I will stop here with a big thank you for your attention. I'm ready to answer any question you may have. The slides will be available online. There are some papers if you want to look at some of the things related to these issues. And I'm all yours.
Thank you, Roberto. Very interesting talk, a highly relevant topic. And I myself have a lot of questions, but I would first let the others ask. So Simon had a question. Simon, do you like to ask? I think it is more lively if you ask rather than I read it from the chat.
Okay.
Okay, I can try. If I can still remember my question. So I understand that you import part of the software from different repositories into the archive automatically, and that there's also manual deposit. What I'm trying to understand is whether there is any sense, whether that makes any sense to apply some kind of filter or threshold, saying, okay, at this point my software is good to be deposited in the archive, or at this point this software which lies somewhere on GitHub, it has to be imported or not. So does that make any sense to filter, or is it easier to just import everything, and then if it's if it doesn't have any impact, it will be just lost as unconnected dot on the graph?
Thanks a lot, Simon, for this. Is a very important question. I mean, it's a key question where you are building an archive. What is your curation policy? I mean, what deserves to be archived, what does not deserve to be archived? I have to say that our strategy is to the antipode of what you see in traditional libraries. I mean, if you go to the National Library and want to, for example, then to have one of the books that you self-publish for yourself, they will just tell you very gently to go away. I mean, it doesn't deserve to go in the National Library. In software, we took the opposite approach to actually archive everything we can get our hands on, because being part of the archive is not a label of quality. It is just making sure it is there in case this object you are developing now, that can evolve tomorrow, I mean, software evolves, may become important later on. So the mantra is, we do not archive software only because we know its value. We archive all software because we cannot know what value it will have. And I have a concrete example. I remember in 1995, I saw this message by Rasmus Lerdorf, which was the original author of PHP. He wrote a single line in the Usenet that said, I'm fed up of writing HTML page by hand. I wrote up a little bit tricky, hacky library. PHP was personal homepage tools. Okay, take it, it's free. So would you have archived that in 1995? Probably not. Okay. Today, it is unfortunately the most popular programming language for writing web pages. So you do not know at the beginning. So we prefer to archive everything. Interesting thing will be pointed at from article, web page, etc. Non-interesting thing will just sediment to the lower level. And thanks to this Merkel DAG, we do not have space problem, space issues up to now.
It's not yet. So Hans-Dieter has also a question.
Yes, my question is it also possible to put into the software heritage archive any software that does not make use of version control?
Absolutely, very good point. So you can actually put in software any kind of software, but there are some subtleties here. So we also track package managing systems. So for example, if your software is just a package in CRAN or in CTAN or in CPAN or whatever, I mean, any of the archives out there which are recognized, we harvest it regularly also. What we did not enable is the ability to trigger archival for anybody without identification of zip files or tar files, because I do not want us to become mega uploader. Okay, but if you want to deposit a piece of software which is just a zip file or a tar archive, etc., we have agreement with these open access portals. For example, in France, through HAL, if you want, you can deposit a tar file or whatever. It is moderated by the people of the open access repository goes here. We are also working with Zenodo right now to extend Zenodo in such a way that there will be direct archival in software heritage. In that case, you can just deposit on Zenodo, it will come to software heritage. If it is a version control system, it is much better to go directly to SafeCon now, because in that case, you get the full history archive. If you go to the Zenodo, the only thing that you get archived is the tar or the zip that you identify or the status of your repository. Okay. So the reason why you cannot right now anonymously deposit a tar file is that the danger of getting crap is too high. Okay. So we prefer to go through other things, but we are working on that.
So we see that the topic is very interesting and a lot of people have questions. So Vadim and Antoine have still questions, and I think afterwards we need to close in order to give some time for the next session. But the two questions I would suggest Jens to take.
Okay, thank you. So to save time on reading the question is, what do you do with attribution? Right, so people can have different account names and whatnot, and if you really want to give them credits, then you want to do something with it. So just in short, what do you do?
Absolutely. Now, let me clarify, because again, probably my presentation on this point was not clear enough. So as software editor, we do not provide credit to anyone. So we just keep track of all the version control system. You have all the information about the Git log, what is the pseudonym of people, etc., etc. But this is not what I believe is the right way of giving credit. The right way of giving credit is actually promoting the use of proper metadata, which is curated, that contains information about you, your authors, etc. And I do not think it is a good idea to just extract automatically from the version control system a list of names, because in this list of names, you could have bots. I mean, you have continuous integration bots and crap and things, and maybe somebody that just suggested you to change a comma. This is not an author. And you will never have the person that actually designed the algorithm and work with the engineers to make sure it works properly. He didn't write the code, or she didn't write the particular Java code because she only knows OCaml, for example, but she deserves to be mentioned. So this is a political work that the team developing the software need to do. The same way we do this political work when we decide who is the author or not in a paper. Okay, who is in the front page, who is in the acknowledgement, and who is just somebody I offer a coffee with him because we chatted. You see, this political work in software need to be done by the team. There is not an editorial board doing this. So what we do, we provide support through this LaTeX software extension to actually do a proper work, but the political work is up to the team. And we also provide tools to write metadata that can be embedded in your system if you have your own agreement on who should be cited. That's much better than trying to extract from the version control system.
Okay, thank you very much. And very cool initiative, by the way.
Thanks.
Thank you.
So the last question from Antoine. Do you like to ask or shall I read? Okay, so for Tamsin, I think I will read. So the question is, what is the policy for removing elements from the archive?
Okay, that's a very interesting question also. Very interesting question too. So the general principle, and you will see this, it's a very similar thing that happens in open access archive. There has been a debate in France about HAL for a while. What happens if somebody wants to remove a paper from this open access archive? Well, the general answer from the archive is no. I mean, it was public, it will stay there. And it can be very touchy, okay? Because maybe you did some plagiarism and you want to get rid of the proofs of your plagiarism, you just want to remove the paper that contains some plagiarism. The answer is no, we keep it because we are an archive. So our answer is, we do not provide easy means of removing things because we are an archive, but we are legally obligated to answer to request of removal as any other content provider, and you have specific legal provision for doing this. So it is not a one-click removal, because this is content that is under copyright, etc. So you need to prove you are your owner. You need to prove you have removed it from every other place around the world. You need to prove a bunch of other things, and this, for the moment, is under French law, because the servers are in France, and since the servers are in France, we are submitted to French law. So there is a precise procedure to follow it. But our general approach is, don't be shy, please share what you have. This is not a label of quality, just make it easy for people to understand what has going on in the software development world, in the research world for the future. And then, of course, if there are deep issues, strong reason to remove something, there is a procedure in place for doing this, but it takes time and it goes through the legal department, which is reasonable. I mean, because you need to prove it is yours, by the way. Not enough to say this is my account on GitHub is not enough for a legal department.
Yeah, thank you, Roberto. So very interesting talk. We see we have also more questions. So this room is there. Now in the coffee.
I will stay here. If somebody has more questions, please do not hesitate. I'll be happy to answer, and the other can take a coffee. And thanks a lot for your time.
So please continue the discussion unmoderatedly. In this online world, we need to live with the possibilities that we have. So you can continue, and others perhaps like to get a cup of coffee. And then we meet again in about 15 minutes, and 10:30. We start with the next session on static and runtime analysis. So thank you once more for the inspiring talk, Roberto, and hope to see you all at the next session.
Thanks a lot. And nice to be with you again. It's a real pleasure, even if virtually.
Roberto.
Yes.
So you talk about Ilko here. So you talk about repositories going away, like
Yes.
what was it, Bitbucket? How do
Yes.
you ensure that the software archive doesn't go away?
Very interesting question. So it was a kind of a big issue since day one, because we wanted to set up a strategy to make sure things don't go away. So there are various levels of measures in our strategy to ensure, well, ensuring, you know, that nothing is sure in this world. But anyway, what is the best we can do? Number one, we decided not to create a company, because company can be bought and sold and shut down. So we are going for the creation of an independent international organization, probably a foundation. If you...
But at the moment you're in a university, is that the...
Yes, at the moment, the current status, okay, if you have a little bit of time, I will explain you really in detail. So my strategy was over 15 years. So the first 5 years, incubation at INRIA. So all the project is working at INRIA to show the world we can do this. I believe now we are at the point that this first phase has ended. So we are providing functionality service that people can test and track, you can do it, and so you can see how it works. Then the second period of 5 years, more or less, is a transition to the final steady state. The final steady state is an independent international organization with proper legal status recognized as an archive. So currently, just in this very moment, UNESCO has set out a call for tender for expert advice on the best organization that could be created to cater for software heritage in the long term. And this is part of our collaboration with UNESCO. But I mean, that's the first point. So we do not want to depend.
Foundations go away too, right? I mean, that's
absolutely. That was just the first point. Then the second point is, how do you ensure money can be there? Okay. Now, the first step on the foundation is on the bylaws, you actually write that your mission is preserving this. So you cannot be bought, you can be shut down unless you don't have any money. And what about the money? So we, as you have seen in the sponsor slide, we are addressing 4 or 5 different kind of stakeholders. So this is diversification of the funding stream.
right.
Which is again another mitigation strategy to not depend on just one thing. And in particular, well, I don't have the slides here, but we try to depend as little as possible on project money, because you cannot run an infrastructure on project money. The project has a start and an end. You can use project money to extend an infrastructure, not to run it. And this is a big issue with the European project in this space, for example. And so we are working on donations and convincing people to be on board for sharing, mutualizing the cost of infrastructure, they address the need. But even that is not enough, because anything can happen. So we have a third level of strategy, which is building an international network of mirrors of software heritage, which are full copies of the archive or the infrastructure, which are maintained and run by other organizations. So they are independent on me. And the idea is that if at some moment one of the nodes of this network we are trying to build will go away, the other node can take up. Right. Currently, we have an agreement with Sweden, with a private company in Sweden, and with Enea, which is a large research organization in Italy. They are building 2 mirrors right now. They are not built yet. So yes, I do not have guarantees today. The software will not go away, but we are really, really trying to do our best to make sure that whatever happens, the data will be there and the effort will not be lost. The final level is trying to get to a European level and try to convince the European Union that this is a new infrastructure which is important for research, and to get regular funding also from the European Union, not just from companies all around the world. but it's a long work. And here you can help spread the word and try to convince more people to come on board.
Yeah. Okay. Yeah, that sounds good. I mean, it's not a single server that
No,
you're depending
not at all.
on.
No, up to now we have 2 in-house copies. I use the term copy as different with copies. A full copy on Azure servers in Europe, which are sponsored by Microsoft, and another full copy on Amazon Web Services, which is on Amazon servers in Europe also. But the 4 are under our control. What I want are mirrors which are not under my control.
Right. And how big are they? I mean, what is the footprint?
You will be surprised. It is 0.5 petabyte. It's not much, because by doing this Merkle tree compression, I mean, it's you deduplicate a lot. So if you have 1,000, and actually we have thousands of copies of the Linux kernel, we just store 1, and then you have links, which are very, very small footprint.
Great. Well, at least I will start telling my PhD students about this, and that they should.
Yeah, so to play with it, and you see.
Yes. Very cool. Thanks. I need to go to.
Go get a coffee. Sorry, I will also.
No, I need to lecture. So.
Oh, okay.
That's
good
day job. All right. See you later.
Yeah, Roberto, sorry if I keep you around.
Go ahead.
Yeah, sorry, my mic wasn't working earlier when I tried to ask the question. Sorry. So I asked the question about the removal policy.
Sure.
The reason why I asked this is because I know a lot of companies, for instance, would hate to have some software that, for instance, are for security researchers in particular.
Sure.
You know what I mean by this, because there's a lot of touchy feelings where companies or governments wants to censor some research in particular. And so I guess the servers being in Europe is okay for most of the governments that like to shut down research in general.
Yes.
But I'm not sure about if you had any pressure or not at that
okay,
phase yet.
thanks Antoine for clarifying what you were thinking about. So I answered a different question from this one before.
But they're both what I wanted, so it's fine.
Yeah. But you are right. And you know, one of the reasons why we are trying to set up an international independent organization under the umbrella of UNESCO is exactly what you are saying. So we must make sure that it will be difficult for any single player around the world, be it a company, be it an individual, be it a state, the government, to actually pressure the organization to do something which is not part of its mandate. And so if you want to get there, it's important to have this independent structure and multi-stakeholders on board. It's really fundamental. And we are not there yet, but this is actually essential for the future, to have this ideally, I mean, if you could dream about this, if you could have the organization set up under a common protocol of agreement by different member states of the UNESCO constituency, that would be a pretty good way of preserving the independence of the organization and avoiding this kind of pressure. Because, you know, today, we believe that being in Europe is safe because I know, and I think we are right for the moment, because we do not feel this kind of pressure, but you never know. Remember, people in 1925, 26, they thought that Europe was a perfectly nice place to be. And look at what happened 15 years later. So it's better to have a really international organization behind it.
Yeah, yes, I agree. Well, this is a really good initiative because I personally am interested in general replication and all of
Absolutely.
this. And I already found my projects in there. So that's
fantastic.
Because I put them on the INRIA GitLab. So they're already there. So that's really good. Thank you. This is very, very interesting for me, particularly. So I'll be keeping track of it. Thank you.
Okay, and if you find your project, you will see that when you visit the page corresponding to your project on SoftwareEdge, there is a small button that says take a new snapshot, or I don't remember the name. So if it is not up to date as much as you want, because we regularly crawl, but we are not Google, you do not have the resources of Google, so you cannot crawl every 2 seconds or 2 minutes or 2 days. You just click on there.
My projects are usually archived in the sense that they're an artifact related to a paper, so they don't.
Okay, so it's fine.
So it's fine in this case. But I was wondering if I should do it as branches, comments, as an archive. But now that I have this linking strategy, I can just post it on the institution GitHub and then save it and then just link it from there, which is much, much easier than just directly linking the GitHub or the GitLab. Yeah. Thank you very much for this. It's very useful because I always link artifacts in my papers. So.
Absolutely fantastic, and try to play with this bibliotic software extension. It's actually pretty fun. You can find it on Citan.
Okay, that's very, very useful. Yeah, because we also use the miscellaneous instruction all the time. So.
Okay.
Yeah, I can relate to that. Okay, thank you very much.
Thank you.
I'm not gonna take more time from you.
So but the next session starts in a couple of minutes. So maybe this is the time to say thanks a lot for to all of you and say goodbye. And now I need to move to another meeting, unfortunately, but I mean, that's life.
Thank you, Roberto. It was really very inspiring.
Thanks a lot, Erika. Have a nice day.
Bye.
Bye-bye.